Welcome to the video here, and in this video I'm going to do an example on multi-level signaling. And this is an applied example. We are not just considering some sort of an abstract signal where I give you some number of bits per signal element. We're going to consider an actual real 802.11b Wi-Fi signal. And we're going to have parts A, B, C, and D, which each use a different modulation format. BPSK, QPSK, 16 QAM, or 64 QAM. This is a realistic problem here. And we don't have to know much about those modulation rates for this, modulation formats for this problem. All we have to know is that in those four formats, respectively, we've got 1, 2, 4, and 6 bits per signal element. And knowing the definitions that we're using here, we're going to assign that M value is the bits per signal element, or per symbol. Okay? And so for BPSK we have M equals 1. For QPSK we have M is equal to 2. For 16 QAM we have M equal to 4. And the last part has 64 QAM, and M is equal to 6 bits per symbol. Bits per symbol. And so I'm going ahead and taking care of this part for all four problems. Putting the units carefully, writing bits per symbol on all of them. And the extra time it takes me to do that, I can sit and think about it for a minute and let it sink in. And in these four problems, either I'm given the bit rate and I'm asked for the symbol rate, as in parts A and B, or I'm given the symbol rate and asked to find the bit rate, as in parts C and D. And we know that the bit rate and the symbol rate are related by a simple equation. RB is our bit rate, and that's in bits per second, or BPS. And RS is our symbol rate, which is symbols per second, or baud. And that they're related by RB is equal to M times RS. So if we know the definitions of M, RB, and RS, and we know this equation, this is a simple problem. Let's go ahead and make the calculations. Here we're after the symbol rate, so RS is equal to RB divided by M. I've solved for RS here, and this is the bit rate, and here in part A, RB is the bit rate, 250 kilobits per second, or 2.5 e to the 5 bits per second. And so we have 2.5 e to the 5 bits per second divided by 1, which is now in baud, or symbols per second, 250 kilobaud. And let's see if I can straighten this out. 250 kilobaud. And so what I did was I just looked back at this and said, look, I don't really need this times 10 to the 5th. I say 250 kilo, 250k, and so I have 250 kilobaud. And I have bits per second divided by bits per symbol, and I get symbols per second, or baud. Okay. For part B, it's much the same. My bit rate is given to me, and it's good practice to write each of these bit rates down before you plug into the equation, 0.5 megabits per second. And therefore my symbol rate is my bit rate divided by M, again solving for RS, and this is 0.5 megabits per second over 2 bits per symbol, and 0.5 over 2 is 0.25 mega symbols per second, or megabaud, or again 250 kilobaud. As a matter of fact, in 802.11b we do have 250 kilobaud is the fixed symbol rate, and in fact that is the symbol rate I give you for parts C and D. Okay, so right here we can see that in 802.11b Wi-Fi we have a fixed symbol rate of 250 kilobaud. We've got varying M values, and they are going to give us various bit rates. For M equals 1, we have a bit rate of 250 kilobits per second. When M is 2, we go to half a megabit per second. When M is 4, let's see. RS is given as 250 kilobaud, and therefore RB is M times RS, which is 4 times 250 kilobaud. 4 times 250 is 1,000, and instead of kilobaud now it turns into kilobits per second, and 1,000 kilobits per second is 1 megabit per second. Okay, so as we go from BPSK at 250 kilobits per second, we go to QPSK, we get half a megabit per second. We go to 16 QAM, we get 1 megabit per second, and let's see what happens when we go to 64 QAM. We have an RB, an RS given to us of 250 kilobaud, and therefore RB is M times RS, which is 6 times the 250 times 10 to the third, which is 1,500 times 10 to the third, or 1.5 times 10 to the sixth, or this is a bit rate 1.5 megabits per second. So we can see here that we have 802.11b, we've got BPSK. In summary, we have BPSK, and we get 250 kilobits per second. We have QPSK, we get 500 kilobits per second, that is half of a megabit per second. We have 16 QAM, we get 1 megabit, and 64 QAM, we get 1.5 megabits per second. You'll notice that we did not ask you to calculate the L in this equation, but L is always 2 to the M, and so the 4 L values here are 2 to the 1, 2 to the 2, 2 to the 4, and 2 to the 6, which are 2, 4, 16, and 64. And you can see foreshadowing of things to come. 16 QAM has L value of 16. There are 16 symbols in the alphabet. 64 QAM has 64 symbols in its alphabet. Okay, hope this helps. Thanks for listening.